Thank you all for joining us today to talk about what's needed effectively to make changes to our current practices to meaningfully increase soil health and water quality in the Lake Champlain Basin. And while most of our time today is going to be focused on identifying next steps, I have invited some folks to join me to provide key bits of information or perspective. So welcome, Mike, Andrew, Chuck. I think Jack is in the room. And Heather, I saw you come in. So great. Thank you all for joining me. I do like to start with just a quick acknowledgement and thank you to my Soil Builders team. So that's Athena Lee Bradley, Mark Companion, Chuck Dupre, who's on with us today, Brian Giroux, Deb Nair, and Ellie Ventura. Additional thanks to our invited panelists and our partner organizations who have been huge supporters and helped in outreach and contributing great content for the Soil Builders program. I'd also like to thank my board of directors and especially the Lake Champlain Basin program and New England Interstate Water Pollution Control Commission for funding this project. So in today's discussion, I'm going to just give a short recap of the Soil Builders Education and Action Program. Then we're going to get an overview of what types of compost and compost-based products are available in the region, some tips and information on how to test material, both from the source at a compost or soil facility, as well as in the field. And then really the bulk of today is going to be talking about identifying missing pieces. So what's needed to increase the use of compost and compost-based products in a way that supports that healthy soil functioning and water quality. And so that's what a lot of this just roundtable discussion is going to be. And I'm really hoping to leave here with some key next steps that we can work on, as this conversation tends to just be iterative and we just need to keep circling around. Okay, so providing a short recap of the Soil Builders program, we've talked about different drivers for changing behavior as part of this program. So understanding that there's an increasing awareness of the full impact of food waste in our communities, connections between landfilling organic materials, methane release and climate change, and then all of this leading to bans of organic materials from landfills, which is really driving more material into our compost facilities and more finished compost and different types of finished compost. There are clean water regulations, which have led to changes in required agricultural practices, as well as updates to the Vermont Stormwater Management Manual, as well as the Municipal Roads General Permits, including, among other things, a post-construction soil quality requirement of amending disturbed soils to a minimum of 4% organic matter content, and understanding how do we achieve that metric and what that really actually means. It's worth mentioning here just briefly, I was in touch with Chris from the Vermont Stormwater Program, and he wasn't able to join today, but he did remind me that we're actually coming up on 5 years since the Vermont Stormwater Management Manual was updated. And so this year is actually an opportunity to be circling back and reconsidering some of the parameters and some of the practices that are outlined in that manual. So all of this work has actually really been important in an understanding of healthy soil and recognizing that infiltration of stormwater into soil is really key to reducing runoff. And so it was actually in the Clean Water Act in 2015 in Vermont that we got a definition of healthy soil in statute, which touches on the importance of well-developed porous structure, chemically balanced, supporting a diverse microbial communities, and having an abundance of organic matter. So degraded and bare soil can be a part of the problem when it's mobilized and goes into the lake, carrying along with it nutrients and other contaminants, both suspended in the water and attached to soil particles. But a healthy soil can be a huge reservoir of moisture and nutrients and act as a filter of all different kinds of contaminants. And all of these modules are available on the CAV website. And so you can refer back to these. I'm just sort of doing a quick overview. But what it really comes down to is management of our soil as a resource and how we interact with different landscapes throughout the basin. The Soil Builders modules touched on a lot of detail about the different ways compost supports and builds healthy soil, the role it plays in regulating nutrient flows, and how it supports healthy plant life. And importantly, that not all composts are the same. And so we really want to focus on using the right medium for the right application to get the desired water quality results. So compost recipe, of course, impacts the nutrient profile as well as the different composition of bacteria and fungal communities. Making sure that it's a stable or mature product is very important. We've had some issues in the past, at least in Vermont, where immature compost was used, not to the desired effect, and that causes problems. And that actually is one of the barriers we've identified for change of practice. And then physical properties of compost are also really important, really focusing on different particle sizes needed for different applications. And then, of course, the importance of lab testing. We've touched on that in a few of the different modules, and we're going to hear a little bit more about that again today. And so knowing that there are all these different composts and different practices, we've touched on what types of products are best for which practices and outlined best management to achieve those desired effects. And so I'm just going to give an overview of the different applications we've talked about. And so that includes turf management, both residential and larger scale, landscape applications, rain gardens, agricultural use, both for field fertility as well as erosion control, and then compost blankets of various sizes and shapes and slopes, the use of sock with compost blankets, and along roadways, all different kinds of, sorry, I don't know exactly how I ended up with a different cursor there, and then berms as well. And so that's the context of what this entire Soil Builders program has building towards. And today we're going to be talking really about the next steps. So now that we know that we have all this compost available and more on the way, and we know that different types of compost are needed for different types of applications, what is available in our area? If a regional approach might need to be taken in terms of thinking through how do we, if we need a low nutrient compost for a certain application, where do we source that from? How do we get it? What are the, is it specs that need to be changed? Is it a different kind of education or outreach, hands-on trainings? What is needed to really move some of this forward? And with that, I'm going to pass it over, I think, to Chuck.
So when we're considering the commercial and public and private compost markets in Vermont in particular, you have a number of different manufacturers at different scales. So from the Green Mountains in the north, Green Mountain Compost in the north of the state, to producers like Tam and Trevor Mance in the southern part, and different producers around Montpelier like Vermont Compost. They have different scales of what they're able to produce. Most of it is heavily food waste based. So then, now that we're starting to examine these different producers, be they large or small, realistically, the best place to start is how do we gather the right information? And so part of the conversation today is we've asked Andrew Carpenter of Northern Tilth, who's a real expert in soil health and compost management and serves with me on the Compost Research Education Foundation, to kind of spend a couple minutes and talk about how you should sample compost or soils. Realistically, collecting a composite, well-made sample, and that seems like an odd statement, but Andrew can expand a little bit, is critical to being able to determine what those next steps are. So either if you're the producer or the end user, knowing how to gather the right information then lets us have that next step. So if Andrew doesn't mind being thrown in a little early, he can start on like, how do we collect the proper sample of compost or soil? And then I can come back and we can get into some more on what to do with it. All set, Andrew?
I'm game. Yeah.
Okay.
Yeah. Natasha and Chuck both asked me to talk about compost and soil sampling because part of this is looking at amending soils with compost, but I'm going to spend most of the time on the compost sampling itself. So I'm going to make this at first a little bit more complex than it needs to be. Ultimately, it is not that complex to get a good composite sample of compost that's representative of the compost that you're buying or selling. But there are a few things to keep in mind. Natasha mentioned the fact that there are, sometimes you'll find immature compost on the market. The first thing to make sure of is that you are ultimately testing the material that's finished, and that is the product that you're actually going to purchase. There are a few reasons for that. There are a lot of transformations that occur during the composting process. There are temporal changes. Obviously, when you're starting out a composting process, you have a lot of fresh organic matter. Microbes are going to do the work of oxidizing a lot of that organic matter during the composting process and ultimately turning it into a more stable product. During that process, the active composting process, you get a lot of changes in temperature, the moisture content itself. One thing that's very important is pH changes dramatically through the composting process. So it often, especially with food waste composting, takes a dramatic dip when the composting process starts, and then it rises considerably towards the end, so that by the time you're done, you have a compost with food waste. It's often a little bit north of neutral, so between 7 and 8, whereas when you start the composting process, you might have pHs as low as 4 or 5 or so. Just another reason that it's very important to get the finished compost, because that's going to be more representative of what you're actually blending or adding to the soil. So you got temporal changes that occur, making it very important that you test the final finished mature product. There's also spatial variability, and this is especially true with larger facilities, and more so even with facilities that might be changing their feedstock from time to time. So it's really important to take into account with your sampling any spatial variability that might be present in the stockpile that you're testing. I'm not going to go into this. We did some for the CREF a while back. We did a sort of a state of the science review of air emissions testing from compost facilities, and some of the spatial variability that you see there, which is great, very high. When I say great, not great in terms of finding a good composite sample, but a great range. Some of that spatial variability you would see with some of the nutrients, organic matter, and things that you're more typically test for in a soil that you're going to be blending with the topsoil. I'm sorry, a compost you'd be blending with the topsoil. So there are a few ways to take that into account. If you're testing a large windrow of finished compost, one thing you can do is use a random numbers table, literally put a grid over, not in reality, but virtually put a grid over the top of the compost windrow and randomly generate areas to sample on that pile. I don't necessarily, I very rarely do this. Typically, I'm just grabbing a random, let me back up a little bit. When you're testing a stockpile, a finished stockpile, we recommend taking 15 grab samples from different areas in that pile, mixing them together to make one representative composite sample. So in this case, this represents using a grid to identify 15 areas to sample on that pile. But really, more realistically, just by taking a look at the pile, you can dig into that stockpile in a few different locations and get 15 different composites. You're typically going to want to do those at different depths. So it is important not to get them from just the very skin of the pile, the outer 6 inches. Always dig in at least 6 inches. And often what we'll recommend is actually, if you have a big stockpile that you're testing, to have a loader or skid steer dig into the pile a little bit so that you can get samples from different depths. So in this case, if we want 15 samples, looking at this large windrow, we have a skid steer bucket loader go into that pile. We might, at each of these 5 locations, get one grab sample each at 3 different depths in these 5 locations. So one at maybe a foot in, one at 3 feet in, and one at 5 feet in, depending on the depth of the windrow. Does this all make sense so far? Hope I'm not over confusing this, because again, it is a relatively simple process, but it's really important that you do get a bunch of grab samples to make one composite sample that's hopefully representative of the entire pile. So again, I'll go back and say, very important to sample exactly what you're going to be purchasing. If it's a screened material, make sure you're getting material from a stockpile that has already been screened. Make sure again that it's a finished pile. And if you see areas that are particularly wet or somehow visually look very different than the remainder of the stockpile, those are areas to avoid, because they'll give you results that aren't necessarily representative of the average characteristics of that material. It is important to have contact with the lab before you sample and determine before you sample exactly what parameters you are going to be sampling for. For most of, I think, what most of the people on this call would be interested in, it's going to be more simple parameters than some of the more exotic ones that we have to look into in some cases. So typically you're probably looking more for things like solids content, organic matter content, and nutrients, nitrogen, phosphorus, potassium, pH, and things like that. Those are typically, a lot of different labs will do it, but I strongly recommend before you go collect the sample, determine which lab you're going to work with, make sure it's a lab that does compost samples on a regular basis, and determine from them exactly how much they need in order to do the analysis, what kind of preservation they need, whether it's on ice, frozen, or that kind of thing ahead of time, and arrange with them when the delivery will show up so that they understand that it's coming. And importantly, so that it doesn't come late on a Friday after everyone's left the lab and sit around, potentially melting and getting hot again before they're able to take it in and put it in the fridge prior to sampling. And then with soil sampling, if you are sampling soil from a stockpile, we recommend doing it the same way that we do for compost. If you're sampling from a field, prior to amending the soil with compost to determine application rates, again, we typically take 15 subsamples from any field that we're looking at amending and composite or homogenize all those samples into one composite sample that's representative of the field. We typically do that in a random manner and avoid areas in the field that are clearly different in soil characteristics than what represents sort of the average characteristics of that field. So very low-lying wet areas you might want to avoid. Certainly areas where materials have been stockpiled in the past or where you believe that the characteristics in that particular area are not representative of the larger field. We did, Northern Tilts made a compost sampling video for the Compost Research and Education Foundation, and that is fairly comprehensive. I think it's about 13 minutes long, but it gives you an idea of a lot of the different things that I'm talking about and what things to watch out for to make sure you don't get a bad composite sample. So it helps you determine the best way to get a good composite sample that's representative of the finished compost that you're either selling or buying. And then one more thing, and I think Chuck's going to get into this as well. If you're looking to, I know some specifications call for a minimum organic matter content. It's a relatively simple way to calculate the finished organic matter of a topsoil that you're amending with a compost. It has to take into account the solids content or the moisture content of both the soil and the compost itself. If you're looking to make it as simple as possible so that you can just have a volumetric blend, like say 1:3 of compost to soil, then you're going to need to know the bulk density of the two materials and the organic matter content on a dry weight basis of both materials. So in this example, we've got a loam that we're starting with at 2.5% organic matter. We know that topsoil is typically around 20% moisture, 80% solids, typically around 2,400 pounds per cubic yard in terms of bulk density. The compost that I'm using in this case is 45% solids, 1,100 pounds per cubic yard bulk density. If we blend those two at a volume of 1 to 3, 1 part compost to 3 parts loam, we would end up with organic matter percentage of 4.3 on a dry weight basis. So if this was even lower to start with, this loam was a really sandy material, that 1 to 1, 1 to 3 mix wouldn't quite do it. So you might have to bump that up to 2 to 3, or probably, I'm guessing 1 to 2 would work here. So yeah, in that case, with the lower, you're starting with the lower organic matter content in the topsoil. If you increase that blend so that the compost was 33% by volume, you'd get up to, and Chuck will get into this as well, on paper, 4.2% organic matter. In reality, it may be a little different in there. So this is just kind of getting you in the ballpark.
Yeah, thank you, Andrew. I think if anyone has time or interest, the CREF video, the Compost Research Education Foundation, is very informative, a good reminder for anyone doing this type of sampling, just readily available on YouTube. The one thing I don't think Andrew, extremely informative overview, the one thing I think he didn't point out, because he probably does it all the time, is that a composite sample, you're collecting more than what you're going to send to the lab. So that's one of the key takeaways that sometimes gets overlooked. You need to make sure you're getting double, triple. If the lab calls for a gallon, you want to have at least 2 or 3 coming out of all your grab samples, so you're homogenizing it properly. More is actually better with this scenario. So yeah, go ahead.
Yeah, it's a great point, and even in some cases, especially where it's absolutely critical that you get this, and there's going to be regulatory oversight or something like that. We'll recommend archiving a portion of the sample as well for future testing. So yeah, that's a good point, Chuck.
Yeah, I mean, that gets often overlooked. I mean, we all have different roles and tasks to do, but it gets overlooked quite often. And that really does affect how you create a statistically relevant composite sample. That's where the number 15 comes from. That's why you oversample, and that's why you have to rely back upon your lab of how much they're going to need in making sure you select the right containers. Because once we have that information, we can kind of move to the next steps of programs like the soil builders and what we're looking to do here in Vermont. So Andrew, I'm going to share my screen now and get in a little bit into some specifics into that soil calculation, just show you how it kind of flows through. Not too much math here on for everyone
on a Monday morning.
Yes, and on Zoom, get your pens and paper out. Let me just pull up my presentation here.
Sure. And you should be able to just.
And I mean, if there's questions, feel free to throw them in the chat here as we're going along, or someone can raise hand and we can, try to expand on them a little bit here. There'll be some time at the end, I'm sure. So again, everyone's kind of familiar if you participate in other aspects of this, conversation over time. But just so we're on the same page today, very briefly, that compost is a soil amendment in most cases. It is not soil by itself. The organic matter and humusy material it provides go combine with inorganic materials like sand, silt, clay, or other materials that you might use to make a soil to improve that soil structure and quality for plant health. Natasha touched upon it briefly, but soil structure, I think, is critically overlooked quite often. That compost can often provide, improved soil drainage, infiltration, just because many times our soils are very fine or degraded, or they're too rocky and they don't really have any other structure. So compost can provide some of that coarser material and some of that finer material that's important for bacterial and fungi functions in a whole homeostasis type system. If you really want to get it, there's primary consumers and secondary consumers in soils. Primary consumers like things that are very small, a couple millimeters across, even smaller. And then there's secondary consumers that like bigger pieces. So compost, one of the benefits over things like peat moss or other very fine particulates is you can get a combination of those different sizes that different bacteria or fungi or nematodes are going to like. So some compost with some structure gives you a good starting point. Many of you are familiar with these terms, but the true AFCO definition of a compost is a humusy rich soil amendment made by the controlled biological decomposition of organic materials. So anything that was once alive. States like Vermont are very heavily focused on food scraps as part of this blend. But anything that was once from the earth can be composted. So getting a little more into some of that organic matter conversation, getting that composite quality sample is an important place to start. It gives you the right information to then make decisions on. So if you've got, first you're testing the compost, be it if you're I would recommend if you're the manufacturer, you're on some sort of regular testing program like the STA program from the Compost Council or your own personal schedules where you're consistently examining that compost. Because as long as your feedstocks are fairly consistent, and I know food scraps might not sound that consistent, but realistically, if it's a percentage of your blend and there's other components and you have a fairly regular feedstock formula, I would say from my personal analysis and many others, you can see a fairly consistent trend in the compost. There might be some variations, but again, gathering that data would let you then know that. So you start collecting data a couple times a year, 3-4 times a year, over a multiple year period, you should be able to have a spreadsheet to say my organic matter average is X and my pH average is Y, and I can kind of follow these things. And many good composters do this already, but it's documenting it, keeping track of it that kind of takes you to that next step as a compost as a business, be it a municipality or a private producer. And Andrew he didn't start to touch upon this, he did touch upon it. It can be very confusing for end users, but organic matter in a soil or in a compost is calculated on a dry weight basis. So water affects everything we do, perfect to this conversation, but that's often removed from the calculation to represent what's in a soil or compost. Because it's everywhere and varies, that's kind of why it gets pulled out. Because you change that water percentage, you can change some of those characteristics. That's what Andrew was talking about, not looking at something like super saturated in a field or in a compost pile. You want to kind of find a average sample that isn't too wet or too dry. Not that that's the most scientific description, but it's the best way to describe it. And it's the same way organic matter will be calculated for a peat moss, if you're familiar with other additives, or soil or compost. This testing and data increases your chances of success. I'll go into it in a second, but Andrew pointed out as well that the spreadsheet you can use to do the calculation, it'll give you a target range. The good thing here is that at least if you know the soil organic matter and the compost organic matter and their types, and I'll get into it, you can make an educated mix that then you can send to the lab to verify what you're looking for. So that's going to be the big help. So you're not going to have to test something 2, 3, 4 times or make multiple mixes. You should be able to make one that should be fairly close, and if need be, adjust from there. Or if you're trying to hit a target range of 4 to 6% organic matter and you come back at 4.5, you're probably consistently in a range you'd be happy with. If you come back at 3.9 and you're looking for 4, I would tell you you're probably on the low end. That's quite often why any specification is designed with a range. You're trying to hit the middle so that one blending batch comes out a little low, one blending batch comes out a little high, and you're ending up consistently in that middle of the range. So very briefly, just so you can see the methodology, I don't want to get too much time on this, but most organic matter content is calculated by loss on ignition. There are other methods. So if you're not familiar with either compost or soil testing, loss on ignition is where the material is often sieved. So the large particulates are removed and then placed in, measured its moisture content and its weight, and then placed in an oven at 360 degrees Celsius. They burn off anything that is organic in that sense. And that calculation is then used to calculate its dry weight organic content. There are other methods, Wakely Black, other what they call wet methods to calculate organic matter, where they use a strong acid to remove that organic content from a soil or compost and try to back calculate it. But it's the same concept. It's done by mass. This method's more popular because it represents all the organic matter in the sample. Some of the older methods use some carcinogenic acids that are no longer popular to be used in the lab. You don't want to work under a range hood. And who loves cancer? So they've kind of gone away from some of those other methods and go towards loss on ignition. Most labs have a kiln type application. I think I've got a picture from UMass coming up showing their methodology. And then TMECC is the methods I prefer from Compost Council, but their method for loss on ignition of organic matter is the same that would be used by many labs throughout the country, big or small. Briefly, you can see what that organic matter spelled out looks like in a lab report, again, just so we're having a similar conversation. There's, if you can see my mouse, there's in the middle the method, so you know that it's going back to what you designed or you're looking for, how it's reported, which is important to know, because then we can do the calculations, and then what the result is. And you can see with Compost Council's methodology and others, they give you the dry weight, the wet waste, the kind of as received number, so you can do the calculation like Andrew showed. I'm going to give you like the cheat sheet version. Andrew gave me the actual table. Glad to share that as well. But it's really driven by density. That's what's kind of confusing often to the end user, is that if my compost is 50% organic matter and my soil is 1% organic matter, mixing them together half and half does not give me 25, 26% organic matter. Because the density difference is so dramatic between these two materials, you end up with incremental increases versus a dramatic change in the material. Very briefly, the numbers on the right I think are more useful for common lawn leaf or food waste based type applications when you're looking at it by volume. To increase organic matter in a denser soil, the common loamy materials, which could be 2,500 pounds per cubic yard, where a compost might be only 900 pounds per cubic yard, again, adjusted for dry weight. Those two numbers are very dramatically different, as you can see, not that I'm over explaining this, but just where this comes from. That means you're going to have to add a fairly large amount of compost to get the organic matter increase you're looking for. And if we're going to have successful programs for healthy soils and stormwater management, knowing roughly how much you need and need to be sourcing or looking at from a design standpoint is important. And these principles apply to a stockpile or in place. So if you can calculate how much soil's in a field or city in situ in a spot versus necessarily just a conical pile somewhere, it's the same concept. It's calculating out the volume. But then you could see back where that data from Andrew's example and collecting a good sample is important, because if my soil sample is off dramatically, meaning it doesn't represent what I've got, when I go to do that test blend or do the incorporation, I might be over applying, which isn't necessarily good for water management purposes, or under applying. So knowing your compost and your soils sounds like a kind of dull moment, but at the same time, that's the critical step to having successful programs and growth of these type of applications. Really briefly, it's back to that final soil testing that you're going to realistically, even if you come up with your own little cheat sheet for your compost at 45% organic matter, doing a final test method on the blend is important. Below is UMass's organic content that comes from the Northeast Regional Publication for Soil Science. Very similar methodology throughout the country, some slight variations in temperature potentially, or how long it's held at temperature. But realistically, 2 hours at 360 C is pretty common to get you a realistic and composite result that's common. And as you can see in what the methods are, if you want to look, anyone can go look at methods. They're doing it only on the material that's ground, so they break up anything that can be broken up, and then on a 10 mesh only. So again, that fairly fine particulate. Compost is done on a larger sample, no sieve, so you can get I think they do a 1-inch sieve. There's something to get off some of the big chunks, but not 10 mesh. This is a real focus on soil. So when I have that data, then I can back into the calculations like we said here before. Kind of a very simplified way to start this conversation. But the next step then is, now that we know what our composts look like and what we have available to us in the market, in the region, well, now we know how to look at that. Then what do we have available to us, I think, is part of the conversation that LCVP and everybody wanted to have today. And I can tell you from Nature Cycle's perspective, a number of producers are importing materials into Vermont, and there's a variety of engineered soil and compost producers like AgriSource that I think could briefly talk to what they see kind of moving around in the New England market, and what kind of producers, be it municipal or private that are shipping into Vermont. We can kind of come back to some more conversation after that, if Mike doesn't mind being put on the spot.
Sure, not a problem. So what we've seen in Vermont over the past couple of years is that some of the larger producers that we've been talking about, Vermont Compost, Green Mountain Compost, even Moodoo, getting away from some of the bulk distributing they were doing, more bag sales that seem to be going. AgriSource is a Massachusetts-based company, so we get calls and we ship into Vermont all the time, and we've been getting more and more interest on us sending materials into Vermont because of the fact that we're starting to hear that there is less available material in bulk for projects. So as far as that's concerned, we ship from all over New England and all over New England our materials. So it's something we've seen more and more the past couple of years that's been of interest going into Vermont. So what it seems like to me is that there might not be enough bulk compost for the projects that are going on, or like Chuck said, possibly some of these suppliers don't have the testing that's needed for a lot of these projects, where you need to know exactly what your source materials are and where you're starting. And that's where companies like ours come in, where we do that type of testing, and we have the volume that we can ship into state. So that's what we've seen over the past couple of years, is a trend more towards out-of-state companies seem to be shipping into Vermont.
Mike,
Mike, you deal with a lot of sorry, Natasha, but you deal with a lot of bioretention, other things. Could you just explain some varying, like, project size? I think that gets confusing sometimes to people that aren't as involved, that how widely varied these things can be in scale and size.
And before you answer that, I'll just tag on one more question, Mike, for you, and we answer them both at the same time. One of the other things that we've been talking a lot about here is different types of compost, so different nutrient profiles. And so I'm wondering as well, when you're talking about the different types of projects, if you could also add a little bit of information about what the compost or compost blend is, what that sort of, like in broader sense, what that nutrient profile looks like.
Yeah, so as far as project sizes, that they can go from a 20-yard retention basin to a 5,000-yard retention basin, where soils can vary greatly. And I think once you start getting those larger projects that you're several hundred yards and above, is where the testing really starts coming into place, it seems like. We see the bioretention soils, and gravel wetland seems to be another larger spec that we've been trying to work with over the past couple of years. Nutrient wise, we do see a lot for a low nutrient compost, which the only really way I know to have a low nutrient compost is if it's aged for a long time and a lot of those nutrients have worked their way through and gotten pretty much washed out through the compost or broken down over time. We do get that question quite a bit. A lot of times what we see with bioretention soils, since compost is a fairly small portion in the mix, your overall soil is not having such a high nutrient content, since bioretention soil is either a sandy loam or a higher sand content in there. Kind of that dilution aspect of it reduces the overall nutrient content in the soil itself. Getting a strictly low nutrient compost, that's been trickier to do.
Do you do any that's just leaf and brush, like yard waste compost versus food scrap or manure based?
We do. So yeah, we do straight leaf and yard waste. We'll do leaf and yard waste with food processing residuals as well. And we also handle biosolids. So all three will have different ranges. Biosolids obviously have the most nutrients out of the three. And we see, depending on what your food waste is, if it's a processing residual or food scraps, I'd say mostly as we're seeing food scraps, vegetables and things like that, with straight leaf and yard waste. It's not a huge difference once you start testing between leaf and yard waste and food scraps. But once you start working more with residuals that have kind of a higher nutrient content to begin with, that's when you start to see the changes in testing.
Yeah, I think Mike's alluding to some of the process of mineralization there within an organic material like compost, that over time the bacteria and fungi break down those organic compounds, mineralize it, use it up. So it means it's less available, less potential for runoff, but that also changes the product characteristics and what you're looking for. It tends to be lawn leaf based, but not all leaves or not all grass, one type, a broad material with a high carbon content to make sure you're using up as much nutrient as possible. But the only way you're going to truly know that usually is either by some sort of data and analysis, either testing the compost itself or testing the soil.
Yeah, and as you're talking about, as you wait over time and things are mineralizing, those organic materials are breaking down further and further. So if you have a minimum content of organic matter, say Chuck had a slide there that was about 30% on leaf and yard waste compost, you let that sit for a while. Now you're looking at 20%, 19, 18. If it's been sitting for a long time, it's continued to break down, become more of a humus type material. So your organic percentages get lower. So it's the trade-off of what you're looking at, either a high organic content, nutrient.
Yeah, Mike is alluding to the true catch-22 of dealing with these organic materials and using them as soil amendment, is there is a finite line of when it becomes most useful to the soil and plants, and when it can become so mineralized and broken down that its effectiveness in a lot of applications might be lessened. So I think Mike is trying to politely get there, but yes, that's one of the potential dangers of focusing heavily on the low nutrient, is that it might be less effective at helping plants establish.
Yeah, and I think the whole concept of the dilution factor. So when you're mixing maybe a smaller amount of a higher nutrient compost with other soils, so we're getting into those blends, that's when you can also meaningfully impact the end nutrient profile of what the material that's being applied to a particular site. And I think that sometimes I've seen references to nutrient profiles for just like the compost component, but if it's going to be blended, you need to really look at it as a whole, right? As the whole function spread out.
And that's that density question again, back to, sorry, Natasha, but then if you're adding 50% compost to a soil, how much of that soil is really still soil? So usually probably looking at a specification that leads to a little bit higher nutrient compost means you can add a smaller amount, keep that soil profile more similar to what it started as, versus when Mike and I see 50% compost blends, it's always a little, it's not the same soil they think it is when you start getting into 50% by volume.
Yeah, I think it's a conversation that we have on engineered soil side a lot anyway, where you have individual components that specifically you'll see, hey, we want XYZ for sand, soil, compost, 3 different specs that are in these ranges, and they also want to see a final mix that hits the certain parameters. Really what we're looking for is that final mix to hit these certain parameters to make sure that the soil is going to perform how it wants to. So as you were saying, maybe it's not just having a low nutrient compost to begin with, but how does that affect the final soil product that we're looking at? So that test on that final soil product is, what we're really looking is that's what's going to be in place, and that's what we want to react.
Yeah. So we have a question about what is low nutrient NPK? And Bob, I don't know if you want to unmute and clarify. Do you mean like what are the actual percents, or what are the, are you looking for numbers, or what are you looking for?
No, I was just wondering what the percentages are, or concentrations in the analyses.
I mean, it's going to depend on your methodology. So, I mean, if we're talking Melic 3 and like standard soils, or maybe a modified Morgan, a percentage point or 2, or maybe less than 100 ppm, and a lot of these things, just the methodology is going to change a lot of it. So I wouldn't want to give you a hard, fast answer, because then if someone doesn't apply the method that I'm discussing, all the math goes out the window is the real problem. Compost are often no more than a couple percentage points, realistically, if it's well made and stabilized, of NP or K.
Well, I typically think of our compost we make in Brattleboro as like a 1-1-1 NPK as an average. And, it varies. So is that low nutrient?
So can I
oh yeah, no, please, Andrew. Sure.
Yeah, if you're 1-1-1 on a wet weight basis, which is typically how those are reported, that's I would say that's not a low nutrient compost. That's pretty good. I mean, from say an agricultural perspective, that's a really nice compost. If you were adding that, for a topsoil blend, it might be it on paper look a little rich, especially at phosphorus at that 1%.
Yeah, because when you translate it into pounds per, cubic yard, it's
Yeah.
hundreds of pounds.
Yeah, it is. And then, one of the things that we're not sophisticated enough to do now, that hopefully we will be in the future, and Chuck alluded to it, is those guarantees, when you're doing a fertilizer guarantee, to give you in your case, the 111. It looks more, the phosphorus in that it's pretty close to a total phosphorus number. It's citrate extractable, ammonium citrate extractable, I think is what the fertilizer guarantee rules require you to use. And that often ends up pretty close to your total phosphorus. And in compost, and which seems to work fairly well for fertilizers, but with the compost, that's not representative really of how much of that phosphorus is going to be either plant available or even environmentally significant. So this is especially true with biosolids compost, but it's going to be true with a lot of compost. If there's a fair amount of iron and aluminum in there, even if you have 1% phosphorus in the compost, and it might look like on paper you've added a lot of total phosphorus, the amount that's actually environmentally relevant and even plant available is going to be a lot lower than that number. But I would say, and I agree with Chuck that you don't want to put a hard number on what's a high nutrient and a low nutrient compost, but a 111 to me sounds like that's relatively high nutrient compost.
Thanks. I mean, I know that there have been some issues with, obviously in the Lake Champlain Basin, with compost for erosion control being considered too high in phosphorus from some of the generators.
Well, and this is Chuck alluded to this earlier. It's one of the one of the tough balancing acts is, even a high nutrient compost is going to help with a lot of the aspects related to water quality in terms of helping the soil to hold on to more water so there's not more running off, and reducing erosion. But at the same time, you do have to balance that with how much extra phosphorus are you really adding. And again, I feel like we're not at a point where we can say, okay, this on paper, I've added, 400 pounds per acre of P2O5 using this compost. Have I really added so much phosphorus that I'm going to have more soluble phosphorus running off of this field after I amend it with the compost than I did before I added the compost? It's a little tough, and that's where I think the low nutrient compost, which to me in a lot of cases aren't as attractive, on paper might look a little better for that reason, because you're both adding the compost, the organic matter that comes along with it, but not as much phosphorus and nitrogen.
Yeah, and Andrew's right back to that question of testing and sampling. The way we test, Scott, a fertilizer made by a company that's water soluble and designed for quick release is very different than compost. So understanding that those numbers are not a one-to-one type relationship is important, especially from a design standpoint. So something that might have a 1-1-1 as a compost might be too much in some applications, but if you dial down into what's water soluble, it might be what you're looking for. It's a complex interaction, and I think not to knock the chemical fertilizer world, but they sold it as a very simple interaction because they were selling very particular chemicals that interact in a very specific way and do very specific things, where natural amendments like compost have a variety of those compounds that interact in a variety of different ways. So applying the same, standards or design concepts is probably not accurate. It's definitely not accurate.
I'd go a step further and say it's ridiculous.
I'm trying to be polite.
Yeah, we've been trying for years, fitting a square peg in a round hole by using fertilizer guarantees to characterize organic matter-based soil amendments, and it doesn't work.
Yeah, I
Well,
think for
thank you,
one,
Andrew, for being blatantly honest, as I usually am accused of. Yeah.
for one thing, it also totally sidesteps the impact of all of that biology that you're adding with a compost or with a natural amendment, which you don't get with these, just these straight up chemical fertilizers. And that further creates a complex system, or furthers the complexity in terms of the interaction and what's available and what's tied up in a compost blend. And I think this all, just to direct the conversation a little bit back to specs, and today we're not really getting into the specific individual specifications. We've done that in a previous module, and those are up on our website for reference. But I do think that what we're talking about here lends some of the confusion to specifying for, say, a road project or a stormwater project, and having folks who may not understand the complexity of this understand how to specify for compost and what that actually, how to interpret that and how to actually apply it in the field. Heather, I know you're on the line. I don't know if you want to chime in from a Department of Transportation point of view and thinking about road projects and compost use, but that's one of the places that we've seen as a potential for growth of compost use and really leveraging, holding our landscape in place with healthier soil. And yet, it's hard to get traction in that, and hard, we keep sort of iterating on the same conversation. So I'd love to hear from you what some of the obstacles or next steps or information needed might be.
Yeah, I'll try to hit on some of those and not lose sight of some of the things that I'm just hearing that are kind of like making sort of bells go off for me and raising my own questions. Because one of the pieces that I know we've talked about before, or I've shared before, but one of the situations where we live in the sort of transportation world, and particularly, being a government agency that's building these projects and putting in infrastructure, is that, it's very prescribed. So we design a project and we essentially create a whole recipe, if you will, about how to build that project. And so the key piece for us is having our specifications. So we have our standard spec book, and within that, we do have an item for compost, but it's more about, if you use compost, here are all the different pieces that it needs to meet. And it's just one spec, so it doesn't really address this issue that I've really come to appreciate after hearing it numerous times, that not all compost is created the same, and you should be using different compost for different applications. So that's sort of the first stumbling block, is that we just have one material spec, as if compost is all the same. The other component related to our specs is that we don't have a pay item. And for folks who aren't familiar with this lingo, a pay item is essentially like the ingredients that go in your recipe that the contractor will get paid for. So most of our projects are very prescribed. They have a whole sheet within the whole set of plans where you see where the roadway or the bridge is going. There's a whole sheet of quantities with every different item that you think you're going to need to do and how the contractor will be paid for it. So we have pay items for clearing trees. We have pay items for common excavation, in addition to the pay items for like the bridge steel. So we have pay items for topsoil, we actually have pay items for fertilizer and lime and grass seed. We don't have a pay item for compost. So it's considered incidental to any other item that is called out as a pay item. So when we have topsoil, you might want to add compost to it to increase its organic percentage, but we don't have a way to pay for that separately. So that's one of the things that I've thought about, that maybe we should adjust. So it ends up sort of, in a sense, being like an afterthought into other things. So it's not as frequently that someone's going to call for compost. Certainly not a contractor because they're not going to be paid separately for it. So those are the two main pieces when it comes to our specifications that I think may offer an opportunity to start incorporating more compost. One of the things I wanted to build on what I was just hearing related to all this information about testing and the interplay between not just the compost testing to see if it would meet the material specification that we do have, but also testing of the soil that you might be amending. We are working towards having a new spec book come out in 2023. And as part of that, we're actually going to change up how we do our turf establishment. So instead of right now, we pay for seed and we pay for lime and we pay for fertilizer, and it's done on like a weight basis. So 10 pounds of seed or 100 pounds of seed. And what we're trying to move away toward, or what we will be moving towards, is an area based. So we want you to establish turf on 1,000 square yards. I'm not sure if that's even a realistic number, but it'll be a square yardage base. And we're also really trying to push the contractors to do more soil testing. So what I'd love to hear is how you might get your soil test results, and how, is there any opportunity that those testing results might identify compost as a way to amend the soil as opposed to just fertilizer? I don't know if that's something that is possible or how that might work, but that is something I'm wondering about. And the other piece is when we go to put compost in for like a stormwater feature, trying to think based on some of the other research I've seen is how we're using it. And my understanding is that in things like bioretention, there have been some tests that are looking at, instead of just putting, if you have 18 inches of this sort of filtering media that's the bioretention media, instead of making it a homogeneous mixture that includes compost, can we instead just put compost in the top few inches to really help supplant the plant growth that's on the surface, and leave the rest of the media free of compost so that it doesn't end up being in a saturated state, because that's what I understand is where we do have more of the nutrient leaching. So anyway, that's a little bit of a brain dump of some of the things that we've been thinking about and I've been considering. So
so let me help tease part of that out, and maybe we'll just sort of start at one of the earlier things that you talked about in terms of no pay item for the compost and just a single spec. And I'd like to lean on my colleagues from other states. So Chuck, Mike, Andrew, and if there's other folks who are from other states who are on the call, please feel free to chime in. But I'm curious about how other states do this. Like, is what Heather just described for Vermont DOT different or the same as in what you've seen in your states, and how, and if it's different, can you maybe help us think through what changes might be needed to help move the needle in Vermont? Yeah, Chuck.
So, I mean, New York State DOT, for my example, allows for an amendment plan. So if you've got the data like we talked about, and you want 4 or 5% organic matter in that finished topsoil for lawn, or 6 or 7% for a planting bed, a compost producer can provide an amendment plan for them, saying that based upon the testing, add 20% by volume compost and mix, and here's the test data sheet, and then that's accepted by the regional LA as a next path forward without an additional test. But you have to have testing on the compost so you can back up the concept. Now that you've got the test on the soil and the compost, you can use the information to come up with your next step. That's one path forward that would make it very attractive to the composter to do testing, because then once they have it readily available, they can just provide a suggested amount to add and proceed to the next step for that soil. And that's what compost mostly provides to that soil from a mathematical standpoint, would be the organic matter. So if you build that into the design and say that our finished lawn soil should have X amount of organic matter, that'll usually cover most of your nutrient need too. And I'm sure Mike's got some thoughts from Massachusetts.
Yeah, similar in Massachusetts, they'll be looking for, say a certain organic percentage in the soil to begin with, and then they'll give the specification for what they want the compost to be. It's a pretty broad range in Massachusetts that they give, so some different types of compost can fit into that spec. So it's not pointed directly towards one thing. A little different where you can't just give the compost report with the soil that you want to see typically a finished material put together. So once that finished material is put together and tested, then that's what gets approved in Massachusetts to use. But typically they'll give you a individual spec for the compost. Like I said, it's a little more broad, so a couple more items can fit into it.
Mike, this is Bob. What about New Hampshire?
New Hampshire's a little not as tight as especially for things like bioretention soils. Their bioretention soil media is a lot of times they don't even ask for compost in the mix. They're pretty low organic matter, sandy loam type of material. So in New Hampshire, it's even less likely to see compost put into some of those bioretention mixes, at least from the state side of it. Private, they can do what they want. And a lot of times we see more similar to Vermont, where you're 3 to 5% organic matter for kind of private bioretention soils.
Andrew, I don't know if you had anything you wanted to add from Maine, or you can also pass.
I don't.
I don't know. Okay.
No, I don't, because I'm not
in that world.
With the
Yeah, no
Sorry.
worries. So one of the things I also wanted to pick up on, Heather, that you mentioned is the bioretention media. And you're right, as it's spec'd right now for stormwater, it's as a single media. And so it's actually specifying that you add compost down to, however deep that goes. And that was one thing that was flagged by CAV and by UVM researchers as well, in terms of thinking like, that may not be the best decision in every case. And really what you want that for is to support the plants, at the top. And you see, there's really no reason to have, an equal blend of, compost all the way down to 24, 30 inches. And that's something that I was in conversation with DEC stormwater program about, sort of on and off. And I know there've been some staff changes, and I'm trying to loop back in and sort of see where we're going to be picking up that conversation. But with this being a year in 2022 where they're going to be looking at those rules again, I know there were some other things that we've been talking with them about making changes to. And so I'm hoping there's an opportunity to address and improve some of the specs that are outlined for stormwater permits. Not just with the bioretention media for sure, but there's other things as well. I think there were some mismatches between what they were calling for and the methodology that they were specifying wasn't quite correct. And so some of those things will hopefully be ironed out in this next iteration. One of our participants, Abby, said that it sounds like from what you described, Heather, that it really is calling for a redesign. And is there a pay item for the soil or compost testing? Like, can people, like how you were saying that you're going to be encouraging folks to test more? Is that something, like, how does that work in to incentivize that?
Yeah, that's a good question. We do not have a pay item for soil testing. It is still considered incidental to whatever other item it's referencing. I mean, the material spec that we have for topsoil does say that, it's supposed to meet these things, organic percentage and other things. So, it's one of those situations where it really is on the contractor to make sure that they're using materials that meet the specifications we're already calling for, but we don't pay for the soil test separately. My understanding is that they're not much though. So that's the message we're trying to get out to the contracting community, that this is what we're trying to really encourage. And I mean, we have language in the specifications that does require soil testing if you have a certain amount of soil that you're using, or if it's been sitting for a certain period of time, but we're not paying for the tests themselves.
Heather, I've seen some states that'll go to the local labs and have them develop a package for them, or at least an identified package. So it's a little simpler for the end user. Like, this is my Vermont DOT topsoil package.
Oh, interesting.
So it just check the box. So there's no confusion. There's some compost states like that where they have their own little bit of a package that this is what they want. So there's no confusion later. And it could be one way to approach. And many of the municipal and private labs or college labs are open to those type of options, brought to them. They just packaging together their existing tests, so you only get what you need, and they also understand that this is what they need to go get tested. They're not guessing.
Yeah.
I have a comment.
Yeah, go ahead, Bob.
I think this is highlighting the need for somehow regional coordination between, states and their agencies, because it's basically a void. I mean, the state of Massachusetts and has their specs, their DOT specs are really not even realistic, and they are now rewriting them through a consultant. And I mean, it's just that bad that their spec it doesn't exist in the real world, unless our buddy from Mike must have explained what's going on in Mass.
Yeah, they're relooking at all their specs. So yeah, we've been contacted by one of their consulting agencies to hey, what have you guys provided in the past? And they're going to other composters and other distributors and manufacturers to see, okay, what's out there, what is available. Some similar to what you guys are doing. We're trying to see what's actually out there. So they are going through, and we'll see what they come up with. But yeah, we're definitely talking with the consultants as well to try and help them with that.
Well, is there any opportunity for New England Interstate Water Pollution Control or some regional group to try to pull together, or at least some discussion between the states?
I'd say at least on the composting side, even talking with different agencies. Yeah, I mean, just in general, talking to different agencies like Mass DEP and things that are going on between states with concerns of other issues. The states aren't talking to each other, and they don't even within the state. Different departments aren't talking to each other. So pretty difficult, I think, to get everybody on the same page. It's ideal. It'd be great if everybody could get on the same page and talk together, but just from the past couple of years of even interdepartmental, agencies, they're having trouble talking to each other. So just to be a little unfortunately realistic about how it's working out so far.
That's one of the things I've been thinking about too, in terms of like, if material is moving, across state borders, but there are different specs and different guidelines and different practices in the different states. And I was wondering the same thing that Bob asked, like how feasible might it be to get like Heather and her counterparts from other states in the same Zoom room to have a conversation? I don't really know if there's Heather, is there a conference that you all go to that you have and compare notes, or some kind of fora for that, or do you have contacts and have conversations with other DOTs in neighboring states?
There are conversations that happen with neighboring DOTs, but I'm not aware of one that's specific to like dealing with all of our specifications. I'm aware that there's a group that of the New England states who are dealing with stormwater issues. And so that is one venue where we oftentimes are meeting some of our counterparts and having conversations. There are a number of other groups through AASHTO that are more nationwide that may be tackling this in certain subcommittees. And so there's opportunity there. It's definitely less of a regional issue. It's more widespread for some of those groups.
Sure.
But I will say that, you know, a lot of times when I'm in meetings and conversations about making an update to our spec, one of the first things that we'll do is say, like, well, what does New Hampshire do? Or what does New York do? Or, you know, have we checked Massachusetts or Maine? So we are oftentimes going and referencing the other states, but it's not necessarily a coordinated effort, if you will.
Can I
yeah.
add something? It
Yeah.
sort of reminds me of a current effort for is related to phosphorus in agriculture, but there is an effort right now in the Northeast. Each of the New England states and New York for a long time has had their own individual phosphorus index, which is a model that NRCS uses in different states to determine potential risk from high phosphorus on agricultural fields. The reason I bring it up is there is currently an effort to come up with a regional phosphorus index, which for us as a company, because we do these in all of the New England states, it would make it a lot easier for us. And it has been an effort that NRCS and the Department of Ag and each of the states have actually been collaborating to some extent. And it may be the case that in a year or so, there will be one regional one. The reason I bring it up is because it might make sense to have some kind of effort, similar effort, related to compost use in DOT projects from state to state. And I think, Bob, you're right. Maybe New England Interstate might be a good source for doing that. And it would allow for not each state to have to hire consultants and kind of reinvent the wheel, and maybe come up with something that has enough stakeholders so that the final product does actually make a lot of sense in terms of, you know, recognizing that composts are variable and what it can and can't do. And
I thought you were saying that, Andrew. It jogged my memory that I think there was a group at Mass DOT that did a research project a few years ago about compost use for transportation projects. So that may be something that, you know, you can follow up on and revisit.
Yeah, I'm sure both the U.S. Composting Council and the board that Chuck and I are on, the Compost Research and Education Foundation, would be interested in at least providing some kind of assistance in something like that.
Yeah, I think Caltrans did something pretty recently, like in the last few months as well. Had more of like I don't know if it was a peer exchange or what type of training it was, but they definitely hosted something, but that was based from Caltrans. But I think that there was another research that was done more locally a number of years ago.
All right, and Heather, you had a couple other questions that I think I interpreted correctly, but I'm not sure. One of which was, could compost, when used in DOT projects, replace the need for commercial fertilizer? And that's definitely possible, and sort of easily characterized by probably in the same steps in which you'd be characterizing. So what does this blend of topsoil and compost do for soil organic matter? So it'd be simple soil fertility testing, but there's no doubt that, like, especially a compost like what Bob is talking about, would it probably would be able to, if it was used as part of the topsoil blend, almost entirely eliminate the need for commercial fertilizer. And then the other thing you mentioned, which I thought was interesting, but I haven't seen in the DOT type projects, is using compost without blending it into the soil or on the soil surface. And I don't know what benefit that might provide, but I think that would be the kind of thing that with some compost might do better than others. a nutrient-rich compost might be a little too rich just on its own to not be blended into the soil, whereas some of the others, as long as they weren't too poor in nutrients and immobilizing nitrogen, might work in that case. I mean, there are we've worked with some farms recently, vegetable farms that are doing just that in order to minimize tillage. Just essentially put compost blankets on top of their rows and plant directly into them.
That's what I was thinking of, that application where you're blowing the compost on the surface of a slope that you are trying to establish grass growth, and rather than doing, our traditional method, which is, to put down the seed and whatever amendments you're using, and then covering it with like an erosion control blanket, that instead of that erosion control blanket, you're using a compost blanket, and that's providing a lot of the same functions, in addition to helping to really spur the growth of the seed, and also provide that much more of like that sponge effect of being able to absorb the water.
Yeah, so I bet Bob, Chuck, and Mike could all probably speak to that possibility better than me. My guess is that you would have to take into account the variability or the different sort of characteristics of compost before determining which ones would be good for that.
And ASHTO has an existing spec for that could be easily incorporated, that accounts for some of that, a vegetated versus an unvegetated blanket.
Well, I think that's what's sort of my point, is there's so much already out there in other state agencies, in specs, that it would be helpful, I think, to transfer this to the Northeast and maybe have a concerted effort to standardize. Although, I know that's probably not realistic.
Yeah. And I mean, you can even mix seed in with a compost blanket when you're blowing it, right, Chuck? I mean, there are instances where you just blend it right there, and it's a little bit like hydroseeding, except with a compost media.
Like Andrew pointed out too, because you're doing things differently, I mean, there are cost savings potentially to the state on no longer requiring the purchase of lime or artificial fertilizer. If you simplify the process, there could be a strong argument that you're, making a cost savings here by just having them do the soil test and amend with compost. Especially adding lime on a regular basis would be fairly unusual for a lot of these soil types. It might be in the spec, but most of these soil types would not really need it to support turf establishment.
That's one of the reasons why we're really trying to encourage the testing. And it's also, when we do roll out the new spec book and stop paying for the fertilizer and the lime separately, the thought is that, hopefully you're really only using it in situations where it's actually called for. Because so often now, if it's part of the project and it's a pay item and I'm going to get paid to put it down, I'll put it down.
Right.
And Heather, I think you had also asked if there were any labs that when you do a soil test, some of the results could come back to recommend certain compost applications. I think one of the problems with that might be that there are so many different profiles with different types of compost. But if any, Andrew, I see you shaking your head. I don't know if you want to chime in if there's.
Well, yeah, I don't know if I'd chime in, but I'd say that it is tough for, it's tough enough for soil labs to give good recommendations. And they do a good job of it in terms of fertilizer recommendations. And they'll even provide some, if you're, say, an organic grower, recommendations for organic type fertilizers. But it does get to be tough with compost because of the variability between the different types of compost.
So it's like we need a translator.
Yeah, well, I always feel like, the thing that makes sense, which is often tougher to do, is make the blend. Like, let's say we're using Bob's compost to make a final topsoil blend for a DOT project is literally make that blend on a bench scale, send it out for analysis, and look at that, as opposed to trying to sort of regulate what that blend should be beforehand. If that makes sense. Like I have a hard time seeing a soils lab take in a loam and test it, and then tell the DOT, okay, this should be blended 1 part compost to 3 parts topsoil.
Right.
It's just too much variability.
Well, as Andrew knows, and he helped me on this, we did have a contractor buy over 1,000 yards 2 years ago to make a blended soil with a very sandy loam. And Andrew made the recommendations. They made the product, and it's sitting in New Hampshire. Mike, you might want to give me a call, but there's probably 2,000 yards of a 4 to 5% organic matter, nice loam sitting in Hinsdale, New Hampshire. But we just haven't had much traction from any contractors or at all to use the material. It's very hard to crack that market.
And the other thing that I've heard from a lot of compost producers like yourself, Bob, and others as well, and also from the contractor side, is that there's also this time lag. Like you can take a soil sample and you can have it analyzed, and then going and purchasing a chemical fertilizer is a very straightforward, accessible thing. But if you then need to add in the step of making understanding what the profile is of a compost, making a blend, having that tested to make sure it meets a spec, that it is expanding effectively the timeline of implementing a particular project. And that's especially in play. And Bob, I didn't know you had that blend available, but so that's good to know. But a lot of the producers, at least in Vermont, we're not stockpiling all these different blends, custom blends for different applications, in part because there hasn't been a demand for it, like we just heard from Bob. And so how do you bridge those things of having the demand, but then, that warrants pre-making blends so you can cut out some of the time lapse that's required if you're doing it custom for every project. And I'm not sure how to crack that nut, but that's an issue.
I've concluded that the way the industry works, and Heather, you probably see this, and is that the contractor bids the job, they get the job, and then let's say a year and a half later, they're ready for 3,000 cubic yards of a loam. They just pick up the phone right then and call their normal contacts, and whatever's available is what they get. It's not like predetermined, we're going to use this blend and it's sitting here. It sort of always seems to be like a last minute, and by the way, we're going to beat you up on price.
But it's back to that testing question. The fertilizer works because it has a label. If we do regular compost testing, now we have a compost label. And I can make decisions based upon that. If I'm not doing regular testing, I can't make educated decisions. It's a catch-22, I know, and it's cost, but that's the catch-22 of it.
I think it depends too on just overall availability, because I think that when people realize that there are shortages, then they do start planning ahead. And kind of nailing things down in advance. It's when you get into this idea that you can just go to any store and pick up the grass seed you want, or pick up the fertilizer, then you don't need to plan ahead. You can just call up and say, hey, I need that, few hundred yards of topsoil. It's when you start realizing like, oh, that topsoil is not available and it's going to be a while before you do have it, that all of a sudden that creates ripple effects for their schedule and not meeting their completion dates. And that's when they're going to really feel it, so that for the next job, they're going to make sure they've secured that source ahead of time.
Yeah, thanks for those comments, Heather.
Yeah. So we're just at the 90-minute mark, and I want to be respectful of people's time, but really great conversation. And I did want to just let folks know that although the Soil Builders grant-funded project is coming to an end this quarter, we are going to be continuing this conversation at the Vermont Organics Recycling Summit in May of this year. So about a month away. That's the first week in May, the 2nd through the 6th, and the Soil Builders conversation is going to be on Tuesday, May 3rd at 10 a.m. from 10 to 11:30. And so that's where I'm going to be sort of pulling together the notes from this. I'd invite any of you to get in touch with me if you have more thoughts or more questions, but I'm going to be looking at how to, what is the next step that we can take, so I'll try to track down what's going on with Mass DOT or that recent relatively new research project that you mentioned, Heather, for DOTs. I'll be talking to Andrew and Chuck about, how to get USCC engaged in this a little bit and trying to problem solve around this, or, is there potential, is there some way to bring in, specs from AASHTO that are missing from our state? Heather, if you have ideas of how, if you're sort of updating your playbook and there are specific needs you have, please let me know. So this is just this next month will sort of be networking, making some phone calls, information gathering, and just in May, another opportunity to try to push this one step forward. What else is needed? And I think it's really through this routine and regular conversation, getting us all engaged and thinking about it. That's the way that we can kind of hopefully nudge things forward. And Abby is asking, could the state proactively test every project site in advance of getting bids, foreshadowing the soil type, amendment needs, and compost profiles to source? Ooh.
That would be
Let's
nice.
put that on your shoulders. No, I'm joking.
It's probably a tall order.
Nice. Yeah.
And one of the real challenges is not necessarily knowing the soil that will be coming onto the site, because a lot of times we are importing the topsoil. There are projects where you're able to just basically take what's there and reuse it, but a lot of the time it's coming in from elsewhere, and that's where it's really the contractors driving the
the
decisions.
Discretion. Yeah.
Yeah. Yeah. It'd be nice to know ahead of time, though.
Yeah. Any final thoughts from anybody in terms of next steps, things I should chase in the next month, or things you want to bring potentially to the session in May? That session as it stands right now is pretty open, and I was sort of waiting for today for it to take shape a little bit. So if you have any burning needs or things, information that I can't believe they're not even thinking about this, there is definitely room to bring that into the conversation that we're going to have in just over a month. Well, thank you so much, all of you, for joining. Andrew, Chuck, Mike, Heather, for being on tap and sharing your perspectives and all of your information. I will likely be circling back to you guys in the coming days and weeks to try to get some ideas generated. Mike, if you have any ideas, because you sort of work in a bunch of different states in your position, I'd love to keep you engaged in this conversation as well and try to figure out how we can get a little bit more of a regional approach going, because I think that's likely what it's going to be needed from what I'm hearing. So, all right. Well, thank you all so much.
Thanks, Natasha.